So this is just a recap of what we discussed in last week. We talked about R and other things, but one of the key things which I want you to take from last week's lecture is about the packages and where they are hosted. So the three primary repositories you can find. There's a CRAN website where you will find packages concerning different fields. So R, which has, if somebody has developed a particular kind of a package in chemistry, physics, or any mathematics, or any other kind of field, irrespective of a particular class, they are being deposited at CRAN website. Hopefully you can see my slide. If you don't, just let me know. I have shared the screen, so I guess it's there. In order to install any of the packages from CRAN website, we use install.packages and within the parenthesis name of the package, and it will get installed. The second resource, which is more relevant from our perspective, is the bioconductor, where most of the packages are biology oriented and are being curated for their performance, as well as with respect to having a help guide for each of those packages. And in order to install any of the packages from Bioconductor, we will need BioC Manager package. And the way to install that one is BioC Manager : install and package name. The third place you can get is from GitHub. Generally, most of the time we won't be doing anything from there, but sometimes it happens in, maybe not now, but during the future when you're trying to do your own analysis, and you come across some package which is being still under development, but the developer has released this beta version. So beta versions are generally the testing versions, which come out and users use it and report any flaws as well as some bugs back to the developer. So if the beta version is available and you want to install it and want to use it, you can basically install from the GitHub using a command install_GitHub. But in order to install, use this particular command, you have to install DevTools. And when you're installing DevTools, you possibly, it may complain of the certain other packages are missing. So in that case, you have to install those packages as well. So whenever you install a package, you see the bottommost line, which it should say that the installation of so-and-so package has a non-zero exit. What we mean by a non-zero exit is generally in software terms, any program when it starts running, when it, can you mute your microphone? Sorry, I'm not sure whose is on, but if you can, that would be great. Yeah, okay. So if an application is running and it finishes without any issues, then it generally called as zero exit, exit zero status. Basically means it has run without any issues. If it has a non-zero exit, it could have 1, 2, or had different kind of exit status numbers associated with them, meaning differently. But that basically means there's some issue during the execution of the command, or in this case, for the installation of a particular package. Once you have installed the package, it is present in your R programming, but it's not by default is available to in your environment. Basically, the functions in that package are not available to use it. Then you use commands like library package name or require package name to load that package. And once that package is loaded, then only you can use the functions. During any course of this time, if you want to remove any package which you have loaded using library, you can use the function detach and give the package name, and that particular program or that particular, you can say, package gets detached or removed from your environment. One more thing I would call, we talk about this double colons in last week's session. I just want to give a really basically a better understanding of what it means. And in this case, I'm taking an example of an ARM package. An ARM package, if you load, let's say you install it, and if you library ARM, all the functions of package ARM gets loaded. And in order to see what all the packages are, what all functions are there in ARM package, you can use the code ls parentheses within the codes package equals to ARM. What it does, it lists out all the functions that ARM provides. And these, you can see there's a list of different functions you can use. Each of these function performs very different kind of operation on the data. Similarly, coefplot is another package. And last time I mentioned about installing coefplot from GitHub. And if anybody has tried, it might have given you an error. The reason behind is that coefplot has moved from its beta version to fully developed package, and it's now available from CRAN website. So you can install it using the CRAN command for installing CRAN packages, which is install dot packages and then coefplot. It will install coefplot. It's no longer available from GitHub. Okay, we have installed coefplot and we have loaded coefplot using the function library coefplot. And if you again, we want to list out what are the functions available in coefplot package, and we'll get a list. Now you can see that between the two, these are entirely two different packages, but has the same function name. Three functions has exactly the same name. That basically means there's a conflict between the name of the function. So when we are using coefplot, we have to make sure that we are using it from the right package. So if you are trying to use coefplot from ARM, we will say ARM : coefplot, and object is the data we are providing for coefplot function. So that's how you specify that the coefplot I'm trying to use comes from the ARM package. If you want to use coefplot from coefplot, then you say coefplot, which is this package, : coefplot. That basically means the function you're using is basically from the coefplot package. Hopefully this is clear over here. Now the question is, do I manually have to check every time I install a package whether it's conflicting with any other package or not? The good thing is, no, you don't have to. Anytime you install a package, it's definitely going to give you a readout whether there is a conflict between functions. So generally, the most commonly you will see something like this. The following objects are masked from package ARM. So in this case, it's telling that these three functions are also present in the ARM package. So when you install any package and load it, so you'll see message only when you're loading the package, not when you're installing. So once you say library package name, you will see this message at the bottom telling, okay, what are the different functions of any given particular package that has conflicts with the other packages. In this case, it's an example when we are loading both coefplot and ARM package. Okay. Sometimes the output, or basically the information is much more clear and much more, you can say, properly displayed. So here, in case when you're loading tidyverse and you have dplyr, it's going to tell you what are the two packages are actually conflicting. So basically from dplyr, there is a filter. From stats package, there is a filter. And similarly, there is a lag function in stats and dplyr, both the cases. So just watch out when you're actually using, when you load any particular package. If I load ARM and coefplot, and if I'm not using any of these three packages, I don't mind. It's okay, that's fine. But if I'm using one of those, then I have to use that : function to specify, okay, where my function is coming from, which package I am calling the function from.
So that means we have to remember that they have this double, or is,
yeah.
If you try to use something, will it automatically report, you got to specify this.
So I'll basically, let me give you an example. Like, for example, here is my R session. And if I say library ARM package, so I'm loading ARM package and it's telling me, okay, it's loading this particular package. Now I say library coefplot. And when I do that, you'll realize that it actually at the bottom displayed the message, okay, this three function has conflict with the ARM package. So you don't have to remember it, but yeah, when you load it, you need to, if you're writing any code downstream, you have to be aware of the fact that possibly these three functions, if I'm using, I have to specify from which package I am trying to use it from. Yeah, that particularly, yes, you have to remember in that way, but not, you can say, keep a track of. When you load these packages, they definitely will give you some information about what are the functions they have conflict with. Does that make sense? Okay, right. So the next thing which I briefly want to talk about is the environment, and you'll come across in different programming languages, whether you're using R, Python, Linux, or Java, or any other, Perl as well. So there is a concept called environment and what it means. I mean, this is a really simple concept, but I just want to introduce you if you don't know about and come across the terminology when you're reading certain manual or looking at certain guide for certain functions. So environment are pretty much similar to our physical environments. The physical environments are primarily designed to serve one specific function, if you think about it. So let's say we have kitchen, we have living space, office, and pub. All of these has very specific purpose to serve. So for example, kitchen is where you cook. So all the needs, what we need, what are the instruments or tools we need to cook are pretty much available in the kitchen. On the other hand, you have basically living space where you want to go and relax. You have your couch, you have your chairs, and you have TV and other things which make you relax. So there's a very specific function provided by each physical environment. Similar to these physical environments, there are also virtual environments. What virtual environment is, virtual environments are to give you or provide you very tools which perform very specific functions. So you can have a virtual environment for an epic array analysis. That's a Mithylome kind of data analysis. And in that one, let's say I'm doing that analysis, the packages I need, I maybe need R4.1.1, and I need some CRAN packages, and I have all these bioconductor packages. So in that environment, I have to load all of them so that all these functions are available to me, and then I can use them. Another concept which is similar in this same environment concept, there is called global environment, and also referred as local or the current environment. There's a global environment is the complete, you can say, if I want to give an analogy, maybe it makes more sense. So if you consider your living room environment, it's a global environment. The whole environment is designed to serve one specific function, to either entertain friends, entertain guests, or you want to relax out. That's pretty much the primary goal of this environment, and it's a global environment. Now, one particular day, if you just think about, okay, I would like to enjoy a glass of wine, and so you bring it a glass of you bring a bottle of wine, get a glass inside it, and some nibbles to eat. So these are what you're doing. You're modifying this environment and creating a small local environment which suits to perform very specific function for a short period of time. And that's a pretty much like a local environment. So for example, once you are done with that particular day, and you want to remove your bottle and basically glass and other things. So next day when you come into your living space, it's pretty much the same. You don't find the glass, no, hopefully you don't find a bottle and anything else. So that's that environment. What you call is it was a local environment just to serve a very specific function, and it was a part of this global environment. And similar are the things which happens in case of all these environments. I will talk about the examples of, let's say, local or current environment when we go into functions, and they serve very specific purpose. And at that time, when I talk about it, hopefully that will make more sense what I'm actually referring to. So this is pretty much what I would like to go over some concepts about environments and packages. So let's go back, and we will going to continue from where we have left. Sorry, just give me 1 second. I'll just deactivate one. Okay, all right. So I have on the left-hand side, I have my source window from where I have the code or the file I have shared with you, which is intro_2_r.r. On the right-hand side is my, you can say, console, where the code gets executed. Or basically, the code is passed from the left window to the right window. The right window is where actually the R is running. So it takes the code, executes it, runs it, and gives me the output. Okay, so I'm going to clean the screen I will make these windows a little bit larger so that it's easy to have more material. So you can click on this larger window at the top. It will basically hide the lower one because we don't using right now. Similarly over here. And we go from here. So yeah, you have pretty much stopped last week by talking about these mathematical operations. So you can do additions. Yeah, any program, as I mentioned last week, like any programming language you start learning, and the first thing they will try to tell you, okay, it works as a calculator, and this is how you do operations. The main idea behind trying to tell you these mathematical operations is because in all our algorithms we designed, or all kind of analysis we design, loops we set up, in all of them we are trying to do we will do some sort of mathematical calculation. So when these calculations meet certain criteria, we do downstream analysis or not, either ways, whichever way we decide. So this gives you an idea, like in this particular language, how each of these things are done. So it gives, for example, addition and subtraction and division are pretty same, but let's say if you get a when you divide 7 by 2, you get a decimal, or in general technical terms called float values. Decimal values are referred as float values. If you read anytime, they're pretty much the same thing. So you get 3.5. But if you have, so let me go one by one, that makes much better sense. So let's say I'm cleaning the screen on the right hand side, and the way to do is use hit Control and L together and cleans the screen. So you have a clean space to work there. So I'm going to go one command at a time on the left hand side. So I move my cursor to the line, and then I hit Control and Enter. The line gets executed. So 2 plus 1, it gives the output as 3. This is how you divide 4 divided by 2. That's the symbol is to divide. Here we are dividing 7 by 2. We are get an output in decimal place, and it's also referred as float values. In some cases, if you don't want to get float values, but want to get a whole number or integers, the way to do is you use %/%. Then it's not going to display the decimal value, but only going to give you the whole number part of the answer. You can do subtractions, and subtractions can be either negative or positive values. You can do multiple value additions or subtractions, whichever way. This is multiplication. 4*4 or 4*4 basically means you're multiplying the two numbers. You can do the real mathematical way of adding and multiplying values. This is the next one is 2 stars next to, or 2 asterisk characters next to each other. Basically means the second number is raised over the base, which is the first number. So essentially 2 to the power 3. That's what it means. 2 to the raise to the power 3, and that is 8. Here 16, again 2 asterisk characters, but that basically means 16 to the power half. Half is actually square root. So the answer you get is 4. Square root of 4, square root of 16 is 4. You can also put half as 0.5, which is same, and it again going to display you the square root. So the next thing which I want to talk about is about creating variables. So all these mathematical calculations are fine, but sometimes we want to store this mathematical calculation so that we can use at a later period of time when we are maybe at some point downstream in our analysis. Why do you want to store it? Why can't you calculate at that time? So here, these calculations are pretty small ones. But if you think about large data sets, when you're trying to look in RNA-seq or basically proteomics kind of data, the number of columns and number of rows goes into sometimes in thousands, several thousands. And if you're trying any of these operations, that will take some time. That basically means it slows down your code. There's no, if you have once calculated something, it's better you store somewhere so that you can, if you want to use it at later, store it into a variable so that you can call that particular value again. Okay. So before going into variable settings, I will just talk about R objects and then talk about object types. Okay. So if you look at in terms of R objects, hopefully you can see it. Okay. The R objects are basically, what are objects? Objects are the containers in which the data is actually stored. And the different types of R objects are vectors. They hold single value or multiple values. And then we have lists. We'll come across all of them one by one, but I just want to introduce these terms before. We have matrix. We have arrays. We have factors. And we have data frames. These are the different object types in which our data will be pretty much, we store our data, whether it's any kind of data we want to import into R. Vectors, matrix, arrays, factors, these has only one type of data inside it. And lists and data frame could have mixed data types. I'll talk about what are the different data types are. And again, this one is mixed data type. Okay. When we talk about basically different data types, then what we can see is the different data types are. If you look at one of them is your data could be numerical. The numerical data is starts from negative infinity and then goes and then -2, -1, then you possibly have 0, and then 1, 2, and then this one. These are the whole numbers, but you could also, this also contains the decimal values also. You can have -2.1 also part of it. Sorry, I could not write it there. I actually have written, but 2.4, 2.5, all those values are also part of the numerical category. Okay. The next is called integers. The integers are more of whole number types. They're from negative, minus negative 2, 2, 1, 0, 1, 2, and then positive infinity. And these numbers don't have decimal values inside it. So those are integers. Other data type is logical. Logical data type is like you're doing some test and the output of it is either true or false. So those your output always going to be either true of that whatever you're trying to test, and or otherwise it's going to be false. One thing to remember is there is a number associated with both of them. True holds a value 1 and false holds a value 0. So you'll see these examples like and it's quite useful when we are trying to do a little bit more coding, and you realize that it's quite helpful to identify certain number of objects in your data set. Then you could have data types which are complex types. We generally don't come across these ones in bioinformatic applications, but they're just for the sake of having information. They are of the type A plus IB. So this is the real part of your basically number, and this is the imaginary part of your number. So that's how the data are. The final one is the character, which is a strings, also referred as strings. In Python, they are called strings. And these are from A to Z. So these are the different data types we are available in case of an R. When I say vector has only one type of data, so only one type of this data would be stored into the vector. Lists could have mixed. Lists could have, you have integers, you can have logicals, you could have character strings, all those can be available in the list. Matrix, arrays, and factors again are, so basically matrix and arrays, either you would have numerical data or you possibly would have an integer data inside it. Factors are true and false. Only again, these kind of data. Data frames are the mixed type. And data frames are, you can pretty much think about them as equivalent to our CSV files. So if you look about, if you have the CSV files, what we have, in columns, we can have either numeric data, just let's say age of certain individuals. Then we can have character also, which is like name. We have also factors like gender of particular individuals. So that is a mixed data type. And the equivalent of CSV file in R is data frames. And that's anytime we import a CSV file, generally that gets stored as a data frame. And we do apply any kind of operations is on that particular data frames. Okay. Now let's go back to our R part. Where is it? Okay, over here. Let me clear it up. Control L. And here, what we're trying to do now is try to set up some variables. So in the first one, what I'm doing is assigning a value X. The value what I'm assigning is 2. So the way to read is X has been assigned a value of 2. So X actually holds the value of 2. Anytime I type X, it basically means I'm trying to get the value what X is holding, that's value 2. I can have Y equals to 5. That's the next example. And hit return. And if you say Y, it will hold the value 5. Okay. You can either have space between the assigning characters. So the one more thing which I wanted to talk, basically forgot to mention when I was doing this one. When you are creating the variables, there are two types of assigning characters you will see. So you will see a variable is assigned a value X equals to, let's say, 2. This is correct as well. And you can use X is assigned the value 2. So these are two ways X can assign a value. This is a more typical of R kind of syntax. So if you're trying to assign variables, try to use this as more often as possible. This one is used generally when you are assigning only a single value. So let's say x equals to 2, x equals to 3. But if you are trying to have if you're trying to assign a variable, a vector or a list having multiple values, then you're going to use this particular symbol over here. And we'll see those examples soon. But I just want to make that there's no confusion that both of equal to and this both signs can we can use to assign x a value of 2. However, this is more preferred in case of an R. Okay, and these ones are used to specify parameters in a function, and we will come across those ones in a while. Since we are using it to specify parameters of a function, most of the coders in R prefer to use this one for assigning variable. I will be using them interchangeably, but a good practice is to just use one of those ones. So you can see that at the top one, I'm assigning x a value of basically 2 by using the typical R assigner, and here I'm using equal to sign. But in both cases, the value get assigned. Okay. The next is I'm trying to assign a value x a string or a stretch of characters. Last character is nucleosomes. So if anytime you specify a string to a variable, you have to put quotes around the variable. Otherwise, it's going to be it's going to report an error. So for example, if I say y equals to test, and it's going to tell me, okay, sorry. If I say y equal to test, hit return, it say object test is not found. Any string character which is not in quotes is trying to think that test is a variable holding some value. So which basically means it's holding some value, means it's an object. So it's trying to say when it says test object is not found, that basically means it's thinking that test is a variable and its value it want to pick up from somewhere. But since we have not specified test, it cannot find it. So the best way to assign test is a string is to put quotes around that, and then it will take it perfectly without reporting any issues. Okay. One more concept which I want to make clear is basically assigning it's called pointers, like how generally data gets pointed in case of R in memory. Okay. So let's see, this is an example. I'm going to run the code 42. What it basically means, the value of 5 is assigned to B and the value of B is assigned to A. Okay, so what we have done is, so now let's test what A holds. The value of A is 5, the value of B is 5. However, let's at some point of time we say y is equal to 6. That basically means the value of B, the value of B equals to 6. That basically means we are overwriting its previous value. So anytime you same variable, if you give a new value, the old value gets deleted, sort of like erased or overwritten by the new value. So here B will hold a value 6. So let's say B equal to 6. Now what happened to X? What value will X hold? So let's try X will, and X is still, so sorry, not X, A. Sorry, that's the wrong one. So because you're using A and B here. So and B, A was holding the same value as B. So we change the value of B. Does the value of A also change? But it doesn't. A is still holding the value 5. Now, why does it that happening? So let me explain a little bit, just give you what actually is happening. So in case of R memory, there are places where these values are held or stored. So let's say there was a place where R was stored, and we created a variable, and the variable what we created was, sorry, A, B, and 5. This is pretty much what the code we ran. So when you run something like that, we have two variables, A and B. Okay. So what happens is the B is pointing to 5. That's where it's referring to. Just because we did this doesn't mean that A is now pointing to B. No, that's not what happens. The moment you do this way, A starts pointing to 5 as well. Now we run a code, say B equals to 6. B is assigned the value of 6. That means there is another object which is holding 6. The only thing happens is that now the pointer of B changed to 6. This gets removed and this change, but A is still pointing to the same value. And that's the reason why basically when we carried out the operation, the value of B changed, but value of A still remains 5. All right. So yeah, there is another function which we can use to create variables, and that particular function is assign. So the way we do is assign, and in the first part of assign is the name of the variable we are assigning. So let's say we have a variable called year. Variable called year, and what we are doing is we are trying to assign it a value. So let's say we are assigning 2022. And now if we say year, it holds the value 2022. This function over here is same as if you write it like this, year assign 2022. This is exactly the same. This is a different way of doing it. The reason why this is, we possibly won't come across too often, but this is quite useful if you're trying to create variables dynamically. What I mean is, let's say you're reading in 5 or 6 different patient data files, and each of the files may have, sometimes you have 5 patients, sometimes you have 10 patients in each of the tables. So if you're creating variables, the number of variables are going to vary between the two tables. The first table has 5 individuals, so you have 5 variables to hold the value of those 5 individuals. The next table has 10 individuals, so if you are trying to do some create some variables holding the value of each individual, you will need 10 variables, and you want it to happen automatically. You don't want to, if you have, like, let's say 50 files like this, it's really impractical, or possibly not it's feasible, but it's, I think, not advisable if you create the variable by looking how many entries you have in the table. You want to automate it in some way, and that automation you can only be achieved by when you can create these variables dynamically depending on number of entries you have in a given table. And that's where the assign variable is used. We will not see these examples much, but I just want to put it out so that if you come across and see something like this, it's basically the same thing as assigning a variable. All right. Here, the next variable we are creating is New York to Boston. Plus size takes 5 hours. So we say NY to Boston, and it is 5, holds the value 5. That's perfectly fine. But the second one, the moment you put a character, it becomes a string. So once you have a character is a part of a number, the whole thing becomes a character. This is called coercion, converting data from one format to another format. And we'll talk about that. How does that happen? But just in a while. So one of the things, possibly, is it here? Okay, we created another variable here called source. And if I try to find source, let me call the source again. And it tells me, this is a variable I created earlier. Sorry, okay. Let me get rid of all. So this is the way to clean off all the variables which I've created. So I'm going to clean them. And let me create those variables again. So I'm going to create source equals to bioconductor. And now if I say source, sorry, again, I'm typing in the wrong place. Type source. And it says source not found. Why is that so? The reason behind that one is that this is the whole is a lowercase, and in this one the s is uppercase. So again, the variable names are case sensitive. If you have these two are entirely different variables now. The source in lowercase and the source with s as caps are two different variable names. They are not exactly the same, or R treats them as two independent object names. So we can store the data in capitals. Let's say this source, assign it a value, let's say data. And now we can call both of them source. This is one source, and this is another source. So both are independent variables. So idea is just they are case sensitive. Next data types I want to talk about are basically integers. Integers and numerics. So we talk about what are in numerics and what are integers. So just going back to the same, or quickly just to, so in case of numeric, the data is from -infinity and goes to, let's say, minus 2.99, and so values, comma, minus 2.98, dot, 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 and then more values here, minus 2, and more values in between, minus 1, more values, 0, and then comma, and then dot, 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 or in between decimal values, then decimal values 2, and then possibly less than a positive infinity. This is the numeric data. Whereas the integers are of the type negative, minus negative, comma, dot, 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 minus 2, minus 1, 0, 1, 2, and infinity. So if we think about it, all the integers which we are here are part of a numeric data, right? So all the data which are integer are also numeric because they belong to both the class. But all the numeric data are not present into integer, so they are not. So all the numeric data, or basically numeric data by default, are not integers. Okay, so but all the integers are numeric data because that's where they belong. It's like this set kind of situation. One is a superset, another is a subset of the other one. So let's create this variable x equals to 3, and so it looks like on the top of it, okay, maybe 3 is a integer because it's a whole value. But however, in R, these values, the numbers which are getting created, are always have hidden decimal values. Unless you convert them into integers, they are not integers by default. So there is a way to test whether a number is numeric, or a number is an integer, or a number is a character. The command is dot type, whatever the type we are testing. So here we'll type is. So for example, we are testing whether the x is integer. So we'll say is dot integer, and we're going to put x. So we're testing whether x is an integer, and it says false, and it's a logical vector now. And the reason behind that is, as I mentioned, by default, these numbers are not integers. That they only now, if you can test is dot numeric, and that's true. So by default, any number you assign to any variable are by default numeric, but are not integer. There is a special way assigning and creating an integer and assigning to it. So you say x, and if you do 3 followed by a capital L, this is the way to tell R that the number you're writing is an integer, the presence of an L. Now, if we say is dot integer, x is going to say true. And we can also say, is that numeric x? That also is true. Okay. Next one is okay, that we have tested. Now, clear it up, Control L. We're going to the y assigned value 4.44. That's a float value or decimal value. We're going to test, is it a numeric? Yes, it is a numeric value. So all the decimal values are numeric. But is it an integer? No, it's not an integer. And we can find out what is the class. Class is like what kind of data type it is. And if we do that, it's going to tell us that it's a numeric. So the value y is holding is a numeric data type. The second one is next one. What we're looking at is creating another integer 7 as C assigned 7L. We check class of C is integer. Now let's say you want to convert this integer into a for example, so the next one is we're multiplying it by a float value, which is 2.2. So the output of this number is going to be a float value. So the moment it becomes a float, it's no longer an integer because it becomes a decimal values. The decimal values are not integers. So immediately it gets converted. If you check the class of C object, SI object, that is a numeric now. It was started as 7L is integer when we created it, but when we multiplied by 2.2, the value get converted into decimal values, and the decimal values are numeric. So it becomes a numeric class. We can do divisions. So let's say, sorry, enter with the class of, if we divide two integers, is going to be a numeric by default. You can hold a value. So the output of this one is going to be in M. So let's see what M is. So M holds the value 2, which is integer 4 divided by integer 2 is 2. And if you check the class of M here, it is a numeric. Somehow in some, not somehow, I mean, we can reassign or change the class of an variable by using the command as dot. So for example, we are going to convert it as an integer, the value of M. And now if you say class M as dot integer M is a numeric and is dot integer M. Oh, that's false. It didn't change it. That's not supposed to do that.
Does it need the 2.2 instead of just the 2?
I don't have 2.2 there. So basically, M holds the value 2, and we can say as dot integer. It converts into 2. Oh yeah, so basically M is okay, right. M as dot integer, and then we have to assign it back to M. So we convert it into integer and assigning that integer to M back, and I think now it should work. Yes, now it's an integer. Basically, when we executed as dot integer M, what happened is the M was is a numeric. It converted into integer and printed it out, but the original M still is a numeric value. It's only for momentarily to convert it and then displayed on the screen, and then but the original M did not get converted. If you want to convert the original M, you have to convert it into integer and assign it back to M, and that's the way you can basically change the class of an object. So let's look at some of the character data. So each of these data types have some sort of an attributes. Attributes are properties which can be exploited to do which can be exploited to basically build some functions, or what we call as methods around them. So for example, in this case, the first what we are creating here is, so before going into that, what are the different basically variables, or what are the different variable names are that is permitted to us? So our variable names can have numbers, basically can have characters, numbers, can have underscore or a dot in them. That's perfectly allowed. The only thing which is not allowed is your variable should not start, basically should not start, not start with either underscore or a number. This is not allowed. So or not allowed, basically it's going to complain. So if you create a variable called 2 star and try to assign it a value, it's going to complain because it starts with 2. At the same time, if you try to do underscore star, that is not allowed. Otherwise, any other types, possibly you can create a variable, whatever you would like to create. And it is basically recommended that when you create your variables, give them a really meaningful name, so that 3 or 4 weeks down the lane or a month down the lane, if you come and revisit your code, those variables make sense. Believe me or not, after some time you try to forget them, and it will take quite a while. It will take you a significant amount of time to decipher your code, because then it becomes like a cipher code or basic, and you take a time. So if you have a very clean meaningful names, that you always use for. Okay, so here the variable, we are assigning the string of characters name to basically variable n. So n holds the character string name. We can say what is the class of n, and the moment you say it says character, so that's what it has. You can convert it into factors. I'll talk about we will talk about what factors are, but let's say There's a one function. So as I said, that each of these data types has certain attributes to them, and based on that attributes, the functions can be made. So there's a function, or there's a method called nchar, or number of characters in n. So in a character object, you can count how many different types of character, how many different characters are not different, how many total characters are there, or number of characters are there. And here there are 4. So there are 4 characters. That's the method that is developed for this one. Now, this is specifically only for character class vectors or character class objects. For numerics and all, it's not going to do it. So for example, if we say X has a value of 2 and we're trying to run nchar, same function as X, in going to complete. Oh, that's not really right. That's not really right. Okay. I'll revisit that one, because my understanding is that they shouldn't be having, unless it's using it as a character. So before I'll go and look at, maybe next class, I'll talk about that one. The other thing is converting your character strings into factors. And what are the factors are? Factors are sort of, you can say categories. So it's a in categorical data, you have categories, and those categories are generally referred as factors. So for example, in a data, if you have genders, you will have males and females. So you have 2 categories for males and females. Similarly, in those categories in R are referred as factors. So you can convert a basically character vector to a factor vector. So for example, here, that's what we are doing. We are converting n, which is a name, to a factor. Do we have to do sometimes? Yes, sometimes we have to convert your character vector into a factor vector. And so one of the easiest one I can think about is, let's say if you're doing RNA-seq or proteomics or any other kind of data analysis, and you have samples coming from 2 different groups, and you possibly groups may have treatment, and then control. So when you import your data, everything will be like character. So you have to convert those characters with the sample class or sample group, which are control. So you have to tell R that, okay, there are 2 groups or 2 classes or categories. One is control, one is treatment. So you have to convert those character vectors, or basically those character values, into factors. So when you are analyzing data, R can immediately think, okay, there are 2 groups, control and treatment. First 3 samples are control, second 3 samples are treatment, and that's how it takes further on. We did a number of characters in N, but there is no number of characters in F, because F is a basically factor vector. Factor vector doesn't have an attribute called nchar, or basically doesn't have any method nchar, or a function that can calculate the number of characters in a factor. So another is, let's say we store the age of some individual, 24. You can see class age is numeric, that's fine. If you put 24 in quotes, immediately that becomes a character vector. So anything in the quotes is a character, irrespective of whether it's a number or it's a actual characters. Once within the double quotes, those things are taken as characters. So for example, you can also have C as, I can say C assigned a value of, within the quotes, true. Now, true and false are actually logical vectors. But here, if you say class of C, is going to say it's character, because it has been in quotes. So even a number in quotes becomes a character. So once it becomes a character, you cannot do numeric operations on it, because all multiplication, division, subtraction can happen only on numeric data. Once your here, let's say for 24, which gets converted into character, you cannot do any mathematical operations. So you have to convert it back into numeric, and there is a function to do it. The way to do it is you say as dot numeric. That basically trying to convert this particular variable age as numeric. And now what you happen, and it becomes 24 is a numeric data. So you can, this way you can convert between different data types. Logical ones are for doing some sort of is an output of certain kind of comparisons, some side of comparative operations we are performing, and the output of that one is either true or false. So let's see some examples of those ones. X is assigned a value of 5, Y is assigned a value 10 divided by 2, whatever is the output is assigned to 5. Now we are testing, is X equals to Y is true. Now remember here that when you're comparing two objects, whether they are same, you have to use 2 equals to sign. If we use only 1 equal to sign, generally the way we say X equals to Y, here what will essentially, if you put only one X equals to Y, what happens? X has been assigned the value of Y. The way we use equal to sign, it becomes an assigner object rather than a comparative operation. So here, if you want to compare two objects, you have to put 2 equal to sign next to each other. We can store this value output of this one in some you can say variable. So let's say here the same operation we are performing, and the output of this operation we are storing in the variable m. So let's see what m holds. M holds the value true. Cool. Now if I say m multiplied by 20, I get 20. Why do I get 20? Basically, but m is holding value true. So if you remember, I told you that they have numeric values associated with it. The true holds the value 1 and false holds value 0. So essentially, when we say true multiplied by 20, we are saying 1 multiplied by 20, and that's why we get an output as 20. These are really funky things, but these are quite helpful. Means when we do some data manipulations, you'll realize that really helpful in using they being holding certain values. Okay. Now this is another operation we are performing. The next one is, what we are doing is X is not equals to Y, but we know that X value of X is 5 and value of Y is also 5. They are same. But if you're testing that they are not equal to each other, that is a false statement. Says the output is false. Same way we stored the output from the last comparison into a variable. Here also we can do exactly the same thing. We are storing the output in T. Now if we check T holds the value false. Now we multiply T multiplied by 4. You get it because it's 0, because false, the value hold is 0. So you get an output as 0. So this is something. You can check the class of M. It's a logical vector because it's true and false. Class of T is a logical vector. Those are basically different. Both of them are a logical vector. Now there's some funny things which is at the bottom. At the start it will looks really funny, but so for example, country is equals to world. It's not same. But if we say country is less than world, it says true. So how does it know that country is less than world? Actually, there is no stored data inside telling it, okay, country is big or world is bigger than country. What it is doing is, when you're saying they're equal, it's obviously performing whether both sides have country values, both sides have world values. No, they're not the same. So it's saying false, but it says country is less than world. What it is trying to compare is whether the alphabetically country comes first or the world comes first. So because the country comes first, so the value will be smaller and world will be coming later. So that's why the country is less than world. There is no other thing. This is just for the fun. I was trying to tell you that when you're comparing strings, what you're comparing is their alphabetic order in which they appear, or the alphabetic order in which you can sort them. Let me quickly look at, so it's 4:57. There are 3 more minutes and I'll quickly look. So any questions so far, or any part you want me to just quickly go over? I'm happy to go over and then explain that one. Okay, so the next thing I'm going to talk about is vectors. Okay, so all the variables what we have created so far are vectors, and basically X assign a value of A. If you say class, basically this is a vector. but vector with only value 1. So most of the times we want something which can hold more than one value. Just not one value is not enough. So for example, we may have a list of chromosomes. So we want to have a chromosome 1, 2, 3, 5, all of them we want to store into an object. So we will need something like that. And vectors can do that. So how do we add multiple, you can say, values or elements in the same vector? And the way to do that one is we use the same assigner. And this time we use the lowercase c, which is, you can say, concatenate, combine, is going to put well together whatever you're going to put there. So you can put like 1, 2, 3, 4, 5, 6. Now x is a variable which is holding a multiple element vector. It has like six elements inside it. Similarly, we can also create vector y, assigning value same way, c, and inside the parentheses, you can have character vectors inside them. You can have a, comma, b, comma, c, and maybe so on and so forth. So you can have as many different values as you want. The only the requirement of creating a multi-element vector is all the data type has to be exactly of same type. You cannot have a mix. If you have a mix, there's something called coercion happens. The one data type gets converted into another one. So if you have a mix of integers and numeric is a bigger one. So everything will get converted to numeric. All your integers also becomes numeric, or the class gets reassigned to numeric. We'll see those examples. Basically, it's already an hour past, so I'll pretty much stop there, and then we can take from there. But so all the basically types of objects, multiple elements you are having in a vector has to have the same type. Otherwise, they get coerced. So if I create, let's say, vector, something like this. So let's say I'm creating M vector. I should take a neat paper. So I'm creating a vector called M, and what I'm going to assign is multiple elements inside it. I'm going to type 1, 2, 3, 4, and then I'm going to say, okay, I'm going to put as character vector also A, and then character vector B.
We're not seeing the paper.
Oh, sorry. Yeah. Okay, I just flipped it, is it? Sorry about that. Okay. So let's say I'm okay. Thank you. Oh, okay. Yeah, that's on the paper. So I'm creating a vector M, and it has multiple element types. And this time what I've done, I put the mixed type inside it. The R doesn't, the characteristics of vector is such, multiple element vector or vector is such that it has to have only one type of object or one class of object. So which way we can convert it? We cannot convert A and B into numeric because they cannot be numbers. But what we can do, we can convert 1, 2, and 3 into characters. So essentially, if you type this one in R, and when you print out R, when you print out the value of M, what you will see is everything has been converted into characters. This is called coercion, like converting one or forcing one data type into other. Okay, so that's we will talk about maybe in the next session. We'll talk about multiple elements. The other thing we'll talk about is like how we pick out these values. Let's say I want to pick up the third and the fourth value from this particular multiple list. How I'm going to do it? I want to pick up from 1 to 5. How I'm going to do that? And let's say I'm going to create a vector of ones. I want to create an M vector of let's say something like that, 5 ones. For some reasons, or zeros or something like that. When we do what you can say, what's called design. Sorry, I got the terminology. Can't recollect. It's an experimental designs you build or design model design when you're doing R. In that case, you create vectors of ones and zeros, trying to tell, okay, which values holds, which are not. It will make sense later on. But how to create, like, let's say 10, a vector of 10 ones or 10 zeros, and how to create a vector which is sequences 1, 2, 3, up to let's say 1,000, if you want to create it. We don't want to type those ones. So there are methods to do that. And how to pick up certain values from the vector, all those things we will basically look into the next class. session. For this one, if you have any questions, please let me know.